Okay, this will be explainer video number 2. I opened up the technician question pool on hamexam.org. So the question pool is all the questions they can possibly ask you. They don't ask you all of these on a test. They pick from each group. So they have a number of questions in a group. Like here, the first one is on safety. So these are all electrical and safety type questions. And there are, in this group, 12 of them. You won't get all 12 on an exam. You might get 1 or 2. They build up like a 50-question exam. So they pick a few of these from each group, and they're very similar often, and ask a question in similar ways. But again, all on the same topic. So you can see this is on power circuits and hazards, hazardous voltages, fuses and circuit breakers, grounding, electrical code compliance, lightning protection, and battery safety. Okay, well, let's jump in. Which of the following is a safety hazard of a 12-volt storage battery? Now, 12 volt is considered to be low voltage. It's not considered to be particularly dangerous, but they are capable of making a lot of current. So let's see what choices they have here. Touching both terminals with hands can cause an electrical shock. Technically, it's only 12 volts, so it shouldn't be such a bad deal. Shorting the terminals can cause burns, fire, or an explosion. That is true. That is car batteries. That's the thing. They make a lot of current, and they can do that. RF emissions from a nearby transmitter can cause the electrolyte to emit poison gas. No. And then all of these are correct. I think it is B. If you short out the terminals of a car battery, a 12-volt battery, it'll make big spark, big bang, and they can create hydrogen gas and they can blow up. So yeah, don't do that. What is the health hazard? What health hazard is presented by electrical current flowing through the body? Well, what do we say? That doesn't sound very good. It may cause injury by heating the tissue. Yep. It may disrupt the electrical functions of cells. Yep. Like the cells of the heart, who may stop beating. It may cause involuntary muscle contractions. Yes, like the muscles of the heart, which may stop beating. All these choices are correct. Yes, all those are correct. Number 3, in the United States, what circuit does black wire insulation indicate in a 3-wire 120-volt cable? Okay, it's like a normal electrical wire. What is the black wire? It is B, the hot wire, by the way. Black is hot, white is neutral, and green is ground. And sometimes you'll see bare copper as ground as well. Okay, question 4. What is the purpose of a fuse in an electrical circuit? To prevent power supply ripple? No. To remove power in case of an overload? Yes. To limit current to prevent shocks? Not quite correct. All these choices are correct. It's B. You remove power when it overloads too much current. It pops and stops the circuit, or breaks the circuit. Therefore, the electricity stops. Okay, question 5. Why should a 5-ampere fuse never be replaced with a 20-amp fuse? Well, if the circuit's designed to safely run only at 5 amps maximum, if you put a 20-amp fuse in, then it can run up to 20 amps and obviously could damage itself and, burn. So the larger fuse would be likely to blow because it's rated for higher current. No, that's the opposite. It would not blow. The power supply ripple would greatly increase. No, it has nothing to do with it. Excessive current could cause a fire. Oh, look at that. I put the mouse on the correct one. There it is. Excessive current would cause a fire, or could cause a fire. That's it. What is a good way to guard against electrical shock at your station? Use 3-wire cords and plugs for all AC-powered equipment. Not a bad idea. Connect all AC-powered station equipment to a common safety ground. Always a good idea. Install mechanical interlocks in high-voltage circuits. So that means an interlock is something that if you try to access the high voltage, it'll disconnect the power. Like inside of an amplifier, if you take the case off, they often have a switch, a spring-loaded switch, that when you take the case off, the switch goes and then it turns the power off to the amp. So it's an interlock. That's a good thing as well. So all of those are correct? Yep, all of those are correct. Number 7. Where should a lightning arrestor be installed in a coax feed line? At the output connector of a transceiver, at the antenna feed point, at the AC power service panel, on a grounded panel near where the feed lines enter the building. That's it. Number D. So my coaxes enter here. So just on the other side of the wall outside, I should put like a copper plate, bolt some lightning arresters. So if lightning strikes, it sends all the power to ground. And you want to do that outside the building because you don't want it to come inside the building. That's the whole point. Number 8. Where should a fuse or circuit breaker be installed in a 120 volt AC power circuit? So it's a house wiring circuit. In series with the hot conductor only, in series with the hot and neutrals, in parallel with the hot, and parallel with hot. Fuses or circuit breakers are always placed in series or in line with the hot wire only. So this would be A. You only put your circuit breaker or your fuse on the hot. That will not be true in a car. When you're wiring a radio in a car, you'll put fuses on both, the plus and the minus conductors. But in a house wiring, they only run it through the black wire, through the hot wire. Okay. Number 9, what should be done to all external ground rods or earth connections? Waterproof them with silicone caulk or electrical tape? Keep them as far apart as possible? I don't think so. Bond them together with heavy wire or conductive strap? Yes, that sounds like that could be right. Tune them for resonance on the lowest frequency of operation? No, that's not it. It's C. You want to bond them together with heavy wire or a conductive strap. So there's little resistance between them. Again, if there's a lightning strike or whatever, it has a nice path to ground. Number 10, what hazard is caused by charging or discharging a battery too quickly? Overheating or outgassing? That sounds possible. Excess output ripple? Boy, they love that ripple thing. Nope. Half-wave rectification? Nope. Inverse memory effect? Nope. It's overheating or outgassing. You might blow it up. What hazard exists in a power supply immediately after turning it off? Circulating currents in the DC filter? Leakage flux in the power transformer? Voltage transients from kickback diodes? Not really. Charge, storage, and filter capacitors? Yes, capacitors hold energy and they don't discharge immediately. Some circuits designed to help them discharge quickly. But you always want to make sure if you're working in a circuit and it has capacitors, especially some big ones like power supplies, you want to make sure that they are discharged. And there are tools for that, chicken sticks, that help you ground them and or through a resistor to make sure that they bleed off. And so if you touch them accidentally, you don't get a shock. So that's the danger, is charge in the capacitors. Okay, last question in this first group. Which of the following precautions should be taken when measuring high voltages with a voltmeter? Ensure that the voltmeter has a very low impedance. Not so sure about that one. Ensure that the voltmeter and any leads are rated for use at the voltages to be measured. That sounds like a good idea. Ensure that the circuit is grounded through the voltmeter. No. Ensure that the voltmeter is set to the correct frequency. You don't set voltmeters to frequency. Well, that's a technical thing. Some voltmeters are rated for higher frequencies than others. Anyway, they're talking about like for measuring house current and stuff. Anyway, you want to make sure that your leads are rated for the voltages to be measured. If you're going to measure high voltages, like in an amplifier where it can be a couple thousand volts, you want to make sure that you're using a lead that is safe at that kind of voltage. Okay, that is the first section. I hope that helps.